Today we'll be discussing the LeetCode problem of the day, design task manager. So in this question, you are given a set of tasks where for each task, you have a user for which the task is assigned and the task ID and also the priority of the task. So initially you are given like a couple of tasks, and then you have 4 types of operations you can do on this set of tasks. So the first operation is like you can add a new task to the existing task. Suppose you have these 4 tasks initially, so you can add another task. Let's say it is assigned to user 3 and the task ID is 107 and the priority is 12. So this add method will add a new task to the existing ones. After that, we have the edit method. So basically in this method, we have 2 parameters. One is a task ID and one is a priority. So if you see in this example, for the edit 1028, that means we go to the 102 task ID and we edit the priority. So I believe it was previously 20. Yeah, as per this input, it was previously 20. So after doing this edit operation, the new priority will become 8. After that, let's go to the top function. So this top function will return the task with the maximum priority out of all these users. So in this example, we see that this task is the maximum priority with 15, and we have to return the user ID. So exec top will return the user ID 3. Also, in case that we have a tie, suppose there's a for the user ID 4, there's another task 107 with the same priority. So in this case, these both have the priority same. So we have to choose a task which has the greater task ID. So this task will be chosen and we will return 4. And finally, we have the return method, remove method. So what this does is you are given a task ID and you just have to delete the task ID from this. Suppose we have this remove of 101. All you have to do is we just have to remove this task from the existing list. So these are the 4 methods that you have to implement. Approach. So we have the input given as a 2D list where each task is given as a list where the first will be the user ID, the second is the task ID, and third is the priority. So we can just convert this into a object so that it will be easier to process. So I've just created a class task where it will have 3 integers. First is user, next is task, and priority. So once that is done, once we have the list of tasks, we first convert each of the tasks into this object and insert all of them into a priority queue. We are using a priority queue because we are interested in knowing the task with the maximum priority. So we can have the priority queue sorted based on the priority. And also in case of a tie, that means in case the priority of 2 tasks are same, we can set it such that it will check which task has the greater ID and that will be given most priority. So for the first input, we have 3 tasks. So I've created a priority queue and added all these 3 objects in the priority queue. After that, we have a query which says that add user ID 4, task 104, and the priority 5. So we have this input like in 3 integers. So we'll just first create an object for this and add it in the priority queue. So the next one here will be 4, 104, and then 5. After this, the next query is like you have to edit the task number 102 and make the priority 8. But we can see that from this priority queue, we can only retrieve the topmost element. So currently the topmost element is this one because it has the most priority, the priority 20. But let's say we have to edit another task with suppose task 103. So we can't directly access it because we don't know where it is in the priority queue. We only know the top element. So given a task ID, so our first problem is we are given a task ID and we have to figure out, we have to somehow get the object corresponding to the task ID. So for that, whenever we add the objects in our priority queue, I've also created a map. So what this map does is, in this map, the key is task ID and the object will be the value will be the object. So while adding this object into my priority queue, I'll also add it in my map where key is 101 and the same thing is the object. Similarly for 102, similarly for 103. Also while adding this fourth task, I'll create one more key value pair in this map with key 104 and the value is this. So once we have this, the edit operation will be easier because we can directly get this 102 task by seeing this hash map. So from here we get this object which is 2, 102 and then 20. Now once we got the object, we have to update the priority. So for that, what we can do is we can create one more object with the same user, the same task ID, but here the priority will be the new priority. So this will be 8. So once I've created the new object, I will insert this into my priority queue. So it will be something like this: 2, 102 and then 8. So once the new object is updated, we can see that this task is incorrect because this priority got updated. So for us to know that this particular entry is incorrect, what we can do is we can change the user ID to -1. -1 indicates that this task is invalid because we can see that the user ID can be from 0 to 10 power 5. So we can safely use -1 to separate out the valid task from invalid task. So yeah, once I have the old task, I will just update the user ID to -1. So once I update here, it will get updated here as well. -1. Also, after doing this, we should also update the map because here also the priority is updated. So this object will be now stored in this key 102 key. So it is 2, 102 and then it's 8. So now this is done. Let's move to the next operation. Yeah. So next operation is we have to return the topmost the priority task. So for that we look into the priority queue and we get the topmost element. So currently this one is the topmost element because it has the priority 20. So the task is -1, 102 and then 20. But once we get the task, first thing we do is we check what is the user ID. So here the user ID is -1. So this task is invalid. So we just remove this from the priority queue and again check what is the top element. So once we remove this, the next top element will be this task as it has the priority 15. So exec top will return you this task and you have to return the user ID. So for this, the answer is 3. 3 is the user ID. After that, you have a query that saying that you have to remove 101. Okay, before this, I think for the 101, the priority was 17. So for 101, we have priority 17. So when we do the exec top, we will get this this task as the topmost element, because 17 is the maximum among these numbers. So that means you will return 1, because you have to return the user ID of the most priority task. So once this is done, we now move on to the remove task. So in this remove function, you are given a task ID and you just have to remove it. So to do that, what we do is we first get the task. We can get it by fetching it from the hash map. So we go to the 101 key and the value is this 1101 and then 17. Now once we have this object, we simply set the user ID to -1, and that's it. So this will also get updated to -1. Now since this 101 is removed, you can also go ahead and remove this key from the hash map as well. That will save some time. And then after this, you have another add method. So this will add 5, 105, and then 15 in your priority queue. And the same thing will be added in the hash map as well. Here the key is 105, which is the task ID, and the value is this object we created. And again, finally, we have this exec top function, which wants you to fetch what is the maximum priority task in this. So again, if we see the topmost element in this priority queue, it is this one, -1, 101, and 17. But again, first step is we check if the user ID is valid or not. So here it is -1. So we just remove it and we again check. So we again check what is the next, what is the top element again. So we see that this and this both have the same priority. But as we discussed, if the priority of both the tasks are same, we then go by the task ID, which has the greater task ID that will have more priority. So exec top will fetch you this task, and you have to return the user ID. So this will return 5. Now coming to the code. So first I'll just create a class which will store all the user ID, task, and priority at a single object. Task, int user, int task, and then int priority, and also the constructor. Yeah, once the class is created, I'll also need a priority queue as well as a hash map. Priority queue, and it will store task objects, pq, and also a hash map. In this hash map, the key is the task ID and the value is again the task object. Map. Now this is where we initialize the priority queue and the map with the initial tasks. So let's just iterate. Before that, we have to first initialize this priority queue. So pq And in this priority queue, we have to implement a custom comparator, which will sort it, which will give it priority based on the priority. And if the priority is same, it will check which has the greater task. New comparator task. So first we will check if a dot priority is not equal to b dot priority. If it's not equal, we simply return which is the greater one. So return compare b dot priority a dot. Yeah, we do b dot priority first, a dot priority second, because we want it in the descending order. And else we will return it based on the task ID. We know that task ID is always unique, so there won't be any clashes. B dot task, A dot task. So yeah, the priority queue is done. So for each task, let's first create a task object. New dot get I dot get 0. This is the user ID and this is the task ID, and this will be the priority. So once the task is created, we'll just add it in the priority queue. Also, we will add it in the map as well. The task ID is in the first position. Task. So the initialization step is done. Yeah, and also I have to initialize the hash map as well. Hash map. Yeah. Now let's go to the add function, add method. So add is also pretty simple. We first create a task object, user ID, task ID, and then priority. Once we have the task, we just add it in our priority queue. And also in the map, task ID, comma, task. So the adding is done. Now let's go to the edit. So to edit it, first we have to get the previous task. Task old equal to map dot get task ID. So this is the reason why we created the map, because we can directly access that object which has the task ID. So once we have the old task, we can go ahead and create a new task. New task. The user ID, you can get it from old task, and the task ID you can directly get it from here, and the priority will be the new priority. So once we created this, we can add it in our priority queue. New task. Also, we will add the same, we will update it in the map as well. Task ID, new task. Now once we have updated the new task, we have to somehow indicate that the old task is invalid. So we do it by just replacing old.user equal to -1. After this, let's move on to the remove function. So for remove, in this question, he assured us that whenever we have a remove, the task will be present in the in the list for sure. So we can directly first get the task from the map.get task ID. So once we have the task ID, the way we remove is we set the user to -1, task.user equal to -1, and also we can clear the key from the map as well. Map.remove task ID. So the remove is also done. Finally, we have the exec top function. So for this function, in this function, he also mentioned that if all the tasks are exhausted, you have to return -1. It is somewhere here. Yeah. If no tasks are available, then you have to return -1. That means if pq dot is empty, if it's empty, then return -1. If it's not empty, then just return the top element dot user. Also, while once we do this task is also removed from the system. So instead of peek, we can just do remove. So this will remove the top element and it will return the user. So the exec top is completed, but we have an issue that previously, whenever we have any invalid task, we used to set the user ID as -1. So what if when we do pq.remove, the top element is an invalid one? So in that case, we have to first remove that one and again check what is the top element. So to handle this, first we just continuously keep removing all the invalid elements which are on top. So while pq dot while the priority queue is not empty, and pq dot peek dot user equal to -1. So while the user is -1, we just remove the top element, pq dot remove, and then we again iterate the loop. So this loop stops either when the priority queue is completely exhausted or if the top element is a valid one. And we are returning -1 if it's empty, and otherwise we are just returning the top element. So let me just test it. pq.remove.user. Okay, I have to return this. Yeah, and submit. The time and space complexity. So first, for the time complexity, we have the initial function which will just create the priority queue and also the hash map. So we have up to n elements, and for each of this element, the priority queue will take logN time. So time complexity for that is n logN, and for the adding task, the time complexity is order of logN, because we are adding it in the priority queue. For edit as well, we are adding in the priority queue, so that also logN. And for remove, again same. For remove, it is just we are just removing it from the map, so it is constant. And for the exec top function, we are again removing it from the priority queue, so it's logN. So, and all of these operations can be called up to 2 into 10 power 5. So 2 into 10 power 5 into this one. So this is the time complexity. Coming to the space complexity, for that we have created one priority queue and one map. So the overall size will be equal to the task length. And it says that up to 2 into 10 power 5 calls can be made in total. So suppose all these calls are made to add only. So the total size will be this plus this. That means 3 into 10 power 5. So which is again same as order of n only. I've also have written the code in Python. So if anyone wants to check it out, yeah, hope it helps.